Hello, everyone. Today we're diving into matrices, a fundamental concept in mathematics and real-world applications. The goal of this lecture is to help you understand the basic concepts of matrices, the main operations on matrices, and some practical applications. Let's get started. Basic concepts of matrices. A matrix is a rectangular array of numbers or expressions arranged in rows and columns. It's used to represent data, systems of equations, or linear transformations. Matrices are typically denoted by uppercase letters like A or B. A matrix with m rows and n columns is called an M by n matrix. Each entry in the matrix is called an element, denoted Aij, row I, column j. For example, matrix A equals the matrix with first row 1, 2, 3, and second row 4, 5, 6. This is a 2 by 3 matrix. The element A23 is equal to 6. Next, let's talk about special types of matrices. A row matrix has only one row, like 1, 2, 3, size 1 by 3. A column matrix has only one column, like 1 over 2 over 3, size 3 is 1. A square matrix has equal rows and columns, for example, 2 by 2 with 1, 2 in the first row and 3.4 in the second. The zero matrix has all elements 0, denoted O. The identity matrix is a square matrix with ones on the main diagonal and zeros elsewhere, denoted I. A symmetric matrix has Aij equal to Aji. A triangular matrix can be upper triangular, elements below the main diagonal are 0, or lower triangular. Two matrices are equal if they have the same size and corresponding elements are equal. Now, moving to the second part, operations on matrices. Matrices can be added, subtracted, multiplied by scalars, multiplied by other matrices, transposed, or inverted. But they must follow size rules. First, addition and subtraction of matrices. Condition, matrices must have the same size. Rule, add or subtract corresponding elements. For example, matrix A is 1, 2 over 3, 4, B is 5 of 6 over 7, 8. A plus B is 6.8 over 10, 1, 12. A minus B is made or 4, 4 over minus or 4 minus 4. Properties, commutative, associative, and has the zero matrix as the identity element. Next, multiplying a matrix by a scalar, multiply each element by that number. For example, 3 times A is 3, 6 over 9, 1, 12. Now multiplying two matrices, this is a key operation. Condition, the number of columns in the first matrix must equal the number of rows in the second. If A is mxp, B is pxn, then A times B is mxn. Rule, element Cij is the sum of products from row I of A and column j of B. For example, A times B is above. First row, first column is 1, head 5, plus 2, 7, 19. First row, second column is 1, 6, plus 2, 8 equals 22, and so on, resulting in 19, 22 over 43, 50. Properties, associative, distributive over addition, but as not commutative. A times B is usually not equal to B times A. Matrix transpose, denoted AT, swap rows and columns. For example, AT is 1.3 over 2.4. Properties, transposing twice returns the original and it's compatible with addition and multiplication. Finally, matrix inverse exists only for square matrices with determinant not 0, called invertible matrices, denoted A minus 1, such that A times AK minus 1 equals I. For example, with A as above, determinant is 14 minus 23 equals negative 2, not 0. Inverse is magnitude 2 coing on a 1 over 1.5, not 0.5. To compute, use the formula for 2 by x2 or Gauss-Jordan method for larger ones. Some examples of matrix applications. Matrices are widely used in various fields. First, in solving systems of linear equations. Matrices represent the system as Ax equals b, where A is the coefficient matrix, x is the variable vector, b is the constant vector. In that case, x equals A minus 1 times b. Second, in computer graphics, matrices are used for transforming images like rotation, scaling, translation. And many other applications in the fields of economics, AI, and machine learning. Thank you very much for choosing to watch my video, and I wish you a lucky day.